the geometric sequence, I'm recording, just make sure you remember that. Going to be 60, 180, 540. So the first one says the geometric sequence. So I told you it's geometric. I didn't actually have to though, because you could have tested for R or D, right? So we know that T1 is 20. We know that Tn is 393,660. We know R should be 60 divided by 20 or 180 divided by 60, which is 3. So then we use Tn equals T1 R to the n minus 1. Tn is 393,660 equals 23. What's the first thing I do? Divide by 20 here. And then T1. And so I get what? 19,680 equals 3 to the n minus 1. 3 to the what is 19,683? 3 to the 9. And then I say 9 equals n minus 1. Add 1, so n equals. The next one says the sum of the first 12 terms, so I gave you n, in the series 18, negative 9, 4.5, the nearest value. So if it's 18 to negative 9 to positive, that's going to be an R for sure. You don't go positive, negative, if you're adding something. Right? So if the signs change, you know for sure it's geometric, just so you know. R equals negative 9 divided by negative 18. If you don't know, you can test it out. 4.5 divided by negative 9. Both is negative 1/2. And then T1 is 18. So I have N, T1, and R. I know it's geometric. One that uses N, Tn, and or T1, N, and R is which one? The first one. So I have S, A12. equals T1, which is 18, R, which is -1/2, to the n, which is 12. Make sure you put this fraction in brackets, because if not, it's gonna tell you it's a negative answer. If you don't go -1/2 to the 12 in brackets, it's gonna tell you it's a negative answer. And negative to an even exponent is always positive. Make sure you put in brackets.
Isn't it
It's 12. You add 1 if it's a word problem. Right there. And this one's, your 1's down here first. And it's not up at the end. Yeah, no, it's beside it. And then R is -1/2 minus 1. So, we're going to get -1/2 to the power of 12 minus 1 times 18 divided by -2. I get 11.99707, blah, 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 which is. Then this one, determine the sum of 7, 14, 21, 98. Am I going up quickly? 7, 14, 21? No, but I am going up by 7. So it's actually D, which means it's actually arithmetic. So how can I test it? 14 minus 7 is 7. And then I can go 21 minus 14 is 7. So I know it's arithmetic because it's a D, common difference. I know I have T1, which is 7. I know I have Tn, which is 98. The fact with sum of arithmetic, though, is there's two things that are non-negotiable. I need T1 and I need N. What do I not have? N. So when that happens, I have to use the Tn formula to get it, right? That's the catch with arithmetic. Every single time you will get one of these, I promise you. So Tn equals T1 plus N minus 1D. Tn is 98. T1 is 7 plus N minus 1, I don't know, ND is 7. First thing I have to do is subtract the 7. I get 91 equals 7, N minus 1. When I divide by 7, what do I get? 13 equals N minus 1. So N equals 14. And now I can find Sn, and I can use the easier formula, which is the second one, because I gave you the Tn. So I can go S14 equals 14 divided by 2. You could have used the big one, but still the same answer, but it's shorter. T1 is 7 plus Tn, which is 98. So we get 7 times 105, which is? And voila. So I set you up for this one because I give you N, right? See if you remember it. Yeah.
It's an arithmetic series. Would you be able to take Tn and divide it with T1 to get N? Because if you take 98 and you divide by 7, you're still going to get 14.
That's not good.
But you can.
However, that did
you
work.
can divide Tn by 8. That's the only reason it works. Not T1.
Yeah, it's because D is 7.
That's the only reason.
It was lucky on that one. If you knew D, you could do it. Only because that would be the way, and only because it's having that D is the same as D. Okay, we're going to go back to quadratics. So, we're going to draw the x squared graph on here first. I could type it into my y equals, but I know it's at 0, 0, 1, 1, 2, 4, 3, 9, up here somewhere. If this was a test, please don't do anything right now. This is stupid, but I'm doing it anyways. I'm a rebel. Don't be a rebel on your test. That's enough time. Okay. And I'm going to label it y equals x squared. My y scale, I may be 1. I should just have went and erased it. It's going to backfire this group. So I now want to put in negative x squared. Go. So in your y equals, type in negative x squared. Watch this. Oh, yes, it is. I'll put that in marker left. So we're going to type in negative, not subtraction. We're going to type in negative, which is by our enter button. Negative x squared. And then we're going to graph. I'm going to type, you're not going to do this, but I'm going to type way down here. Don't do this. I'm just going to show you. X. So what does it look like happens when I just show that negative in front? It goes downwards. Yeah, it's upwards above the x-axis. Now it's downwards below the x-axis. It actually is reflecting in the x-axis. It's as if the x-axis is a mirror and it's reflecting itself down. Okay? How do I get my table of values? I go second, graph. There's our table of values. So I'm going to put in 0, 0, negative 1, negative 1, negative 2, negative 4, negative 2, negative 9, negative 2, negative 4, 3, 9. And look, if you look, this is the x squared one. It's just these ones negated. Do you see that? All my y's just get negated because it causes it to reflect down. So we're going to go 0, 0. That point didn't change. It remained invariant. Negative 1, negative 1, 1, negative 1, 2, 4. Look at this. I'm not going to draw the 9s because they're off. This is y equals negative x squared. Mason, do you want my calculator?
Yes, please.
Now I'll put my. We'll use it, so. So, what's the vertex of that one? Of the red one? Of the y equals negative x squared one? What does it look like it's at? 0, 0? How did we find it last day? How did we find it? Yesterday, we went second, trace, minimum, because it was minimum, right? It was a minimum yesterday because it was concave up. This red one's concave down. What is there now? Not a minimum, but a maximum. So when they're concave down, you have to pick the maximum button, which is number 4. So we're going to go second, trace, maximum, which is number 4. And now it says left bound. I need to be on the left side of that. Somewhere, anywhere. Enter. And then right side. Now if you picked minimum instead of maximum, it's going to fight you. Because there's no minimum on this one. What does it give me? Some crazy decimal e negative 7, some crazy decimal e negative 14. What did the e negative 7 and the e negative 14 just represent? 0. So isn't that 0, 0, which it certainly looks like it's at 0, 0, doesn't it? This just proved it. So our vertex is at 0, 0. What's the direction of our opening for negative x squared? Down. I told you we're not going to really worry about the main range at this very moment. We're going to get through and do all of these this way, and then we'll come back. What's the axis of symmetry? What's the line that cuts the graph in half? It's x equals always. And it's 0. It's always the x to the vertex. X equals, and then this is just x to the vertex. You're not going to write this in quotes. It's just, you find out the vertex and you put the x value here, right? It's 3, 7, 9, whatever. If my vertex was at 3, 7, let's pretend, my axis of symmetry would be x equals 3, because it's whatever the vertex x value is. Okay? But we've just got with zeros up until now. It's not going to say that way. So you go into your calculator and type in negative 2x squared. This is why I'm going to regret. Thank you, my wife's going to figure. I'm going to put in my y too so I can see it. Now remember, I taught you that you can make the second one a thicker line, correct? Did I teach you that? I can't even remember. Oh, life changing. Okay, we're gonna go to y equals. If we graph two graphs, I can tell the difference, right? I look here and I'm like, hey, red is the second graph, blue is the first graph. It tells me that. But most of you don't have colors. So that's lovely. It always draws it in order. Good to know, till it's drawn, and then you go do some math and you come back and you're like, oh crap, which one was the first one and which one was the second one drawn, right? That's hard. But what you can do, and for me this doesn't work because I have the colored ones. If you have the colored ones, don't follow me. If you have the not colored ones, follow me. You're going to go over here, and you're going to go to the slanted line. You don't have a color, you just have a slashed line. Do we agree? And you're going to do this on Y2. I always do it on Y2. I leave my Y1 be the thin line. Then I hit enter once. And it makes it a thick line. Do you see that? Don't hit enter 800 times. You know what? I'm going to life ruin it for you so that you don't all start pushing buttons and not listening to me after this moment. It will give you one that looks like a key. It just draws like a circle with a slash. It will give you a dashed line. It will give you one that shades above. It will give you one that shades below. You don't care what it does. So I don't want you to spend the next 10 minutes pressing the buttons to see what it does. I just ruined it for you. Told you what it all did. So now you can press it once and get a thick line and press graph and move on. So just prove it to all of those buttons. Okay, good. Press graph. One of them will be thicker. Do you see that? Then you'll know that the thicker one is actually the second graph, right? Then you go do some work, and you come back and you're like, oh, okay, I know which one's the second. Or you're like, oh crap, I don't remember which one I put in second. Well, you press y equals and it shows you. So I always make my second one the thicker one, and it's always consistent. Okay? Pressing it back more.
Where's the key one?
No, it literally just draws like a circle with a line. Oh.
Is it gonna break your calculator?
Sure, it'll break your calculator. Okay, so.
No, it's so much. Okay. No, it gave me a little half square.
Oh,
No,
wow.
it didn't.
How are we, like?
No, it gave me a little. Oh, I found the key one.
Yeah, look at them all.
Oh!
Wow, they'll shade above and below too, it's crazy. It's amazing.
That was a cool exam skill there.
Little things in life.
That
Okay,
is.
at this point, if you don't pay attention on you. All right, so we're gonna go, and I'm gonna take out the negative x squared. But if you look here, the red just got narrower, right? Because it pulled it faster. So the 2 actually makes it narrower. We said that yesterday. The 2 made it narrow, pulled the y's out faster, and the 0 to 1 made it wider. Correct? We agree? It's still going to do that. The 2 is still going to narrow it. The half would still widen it. The negative doesn't do anything about widening or narrowing. The negative causes it to reflect down. Yeah, it just puts it down. So the number in front is what actually makes it narrower or wider. But the sign in front makes it concave up or concave down. So if the sign in front is positive, it's up and has a minimum. If the sign in front is negative, it's down and has a maximum. So I'm going to take this one out just so my table of values are easier. So I go second graph, and that's the only table of values I have then. So I'm going to plot -2, 8, -1, 2, 0, 1, -2, 2, -8. So -2, -8. So I said I regret representing the y scale of 2. And then -2, 2, 2. Do you see how the 0, 0 didn't change? I don't know. You see how this stayed 0, 0? It's actually called invariance. It didn't change. But the graph got narrower. So I go to find my vertex because I want to find my maximum, correct? Is there a button that says second trace vertex? We went over this. Is there a button that says second trace vertex? No. You need to know that there's a max min button. Those are the options. That's what gets you the vertex, right? There is no second trace vertex button. So once again, I would go second trace. This graph is a maximum. So 4. Left bound. Enter. Right bound. I go right over here. I go down here, here, there, here. Any of these places. Enter. And then hit enter, and I get e to the -6, e to the -11. So what's it at? 0, 0. and it's down. And what's my axis symmetry? X equals the x of the vertex. What's the x of the vertex? 0. I'm not going to worry about this box down here. Actually, you can. Develop a rule. If a is greater than 0, a is greater than 0, a is what's in front of your x squared. So if a is greater than 0, so say I have y equals ax squared, that's what we're going to look at, okay? If a is greater than 0, what does it tell me about the graph? It's concave up. So if a is greater than 0, that means it's positive. If a is less than 0, that means it's negative. What happens when your a is negative? It's concave down. What happens when your a is between -1 and 1, so a small fraction? What happens to the graph when it's smaller? Graph actually widens. And what happens when it's greater than 1 or less than -1? Like the 2 and the -2 we just looked at? Graph. So that was of the form y equals a to the x, or ax squared, right? Ax squared. Now what if I look at a form like, oh, sorry, we're going to go back and do the domain range. So we go back one page. The domain, so we have the graphs all drawn for us, right? They're in front of our faces. The domain is what x values exist on this graph. So if I look at a parabola or a quadratic like we have here, does x exist at 0? Yes. At 1? Yes. At 2? Yes. At 3? Yes. At all the spots in between? Yes. And all the way to positive infinity? Yes. I can find an x somewhere along here. This x line at -1, -2, -3, all the decimals in between and forever? So if I can go like this, like, praise the Lord, my domain is XER, because every x value exists in the world. X is an element of the real. So how we write it is you write it like this. Squiggly bracket, they call it curved bracket. I don't know call it squiggly. You can't make it round, you can't make it square, you have to make it squiggly. It literally doesn't mean the same thing, and I'm not joking, like it's not a haha. It has to be squiggly bracket. Well, we'll see if it looks relatively equal. So then we go x, because that's the variable we're using, is x. If this happens to be like f of m equals m squared, I would say squiggly bracket m. Whatever the variable is for x, right? It's just always going to be x, so that's great for you for this year. So squiggly bracket x, and we do a straight up and down line, which means such that. We do squiggly bracket x such that, and why do we do this? Because we're saying the variable is x for x. It could be m, it could be p, it could be whatever, right? But it's x. And then we say x is an element of the real numbers. Now the reason why we say that is the real number system taught last year in grade 10. The real number system is every number in the world. So it could be integers, so the negatives and positives. It could be naturals, like 1, 2, 3, 4. It could be decimals that repeat, decimals that terminate, like rationals. It could be decimals that carry on for life, like a pi, like irrational numbers. It's the real numbers. It's all the numbers in the world. So when you use R, it means that you can find every x value on here. All the real numbers exist on this graph. And so when you can start at 0, 0, and your arm goes to the right up, and your arm goes to the right left, every x value exists, right? I just did it with my arms, so it exists. So what can you say about quadratics? They're all going to be up like this, or they're all going to be down like that. What can I say about my domain? For every quadratic, it's going to be XER, unless it's a word problem. So domain in this unit is like fantastic. But unless it's a word problem, it's XER. Because whether it's concave up or concave down, it's XER. So your domain's always going to look like that. Don't believe me? Let's go down. One more here. Are all of these going, woohoo, praise?
Yeah.
Every single one? Their domains? This one should be fixed. Just like this. X such that X and all of it. Flip over to the next page. Now it's going like this, downwards. But are they still starting at 0, 0 and going down? Yeah, so what are they? x such that x and now in the reals. X such that x and now in the reals. See how my domain didn't change? Because as long as I started at a max or a min and I go outwards, I'm getting every x value in the world, all the real x values. Now range is not the same. Range is what y values exist. So if I look at this very first one, on the very first page, are there any negative y values down here? Is there anything down here? Where does it start at? 0, and it goes, what's another word for up? In an inequality sign. No, in an inequality sign. The only options are greater or less. So up would mean greater, right? Now, so it starts at 0. Does it equal 0 here? Yeah, so it's equal to, or graph is greater. So the lowest part it is 0 or greater. Do we agree? That's not crazy, is it? Starts at 0 or greater. Do we agree with that statement? Because if you can agree with that, range is really easy. Starts at 0 and it's greater, correct? So our range is going to be, what variable are we using now? Technically y, and in this case it's actually f of x. They're using f of x in the y spot, aren't they? So we would have to use f of x. If this was y equals x squared, I'm going to show it in 2 columns.
This is the squiggly line?
Yeah, because it means the set of. The squiggly line means the set of. It means actual math. So we'd go f of x, because that's our y variable, such that f of x, and what did you tell me? It's greater than, so it's open to it, or equal to, so we put a line. What is it greater than or equal to? What's my y value that's greater than or equal to? 0. And then I follow behind with f of x er. And the reason why I do that is the f of x is greater than or equal to 0 limits my y's that I can choose from. And then what it says is all the y's that are greater than or equal to 0 are actually real numbers, which these are. It's all the decimals in between. Boom, goes up. So had it been, the equation been y equals x squared, let's pretend the equation was that. My range would be, squiggly bracket, what was my y in this case? Y. It's just y, isn't it? That one is f of x, this one is y. So I would go, what variable did I use for my y? Y. Such that y's are greater than or equal to 0, all the y values greater than or equal to 0, and then of those y values greater than or equal to 0, I picked all of the real ones. Everything from 0 and above, which includes all the decimals, everything, right? So if there's no gaps between your points, your coordinates, then it's real numbers every single time. So we go y such that y is greater than or equal to 0, y is an element of the reals. Oh, that was not recording, thank goodness. So the only thing that changed there was my f of x's were y's because the variable was a y. That's it. If they called it g of x equals, I put g of x in for my y's, right? Whatever the variable is in the equation. So what about here? These ones are using f of x, aren't they? Where's the lowest all of these go to? 0 or greater. So are they all not going to have the same thing? Yeah. And what was my equation? What was my y in all of these? F of x. So I'm just going to write it along this whole thing because it's the exact same. So I'm going to go squiggly bracket. What's my variable for y? It's f of x in both of these. So I can go f of x such that y, or in this case f of x, is greater than or equal to, what's my lowest y? 0. And then I follow behind with all my y's, my f of x's, are an element of the real numbers. What's great about quadratics is it's either going to be greater than or equal to your vertex y or less than or equal to your vertex y. When do you think it'll be less than or equal to? When the graph is concave down, you're going to have a maximum y, right? Oh, look at this. Here it is. Boom. Look at that. So, for these two graphs, the red and the green, my y is f of x, so I'm going to use f of x. That's the variable they gave me. So I'm going to go f of x such that f of x is what this time? Less than or equal to, because the whole graph starts at 0 and goes downwards, right? Less than or equal to, what's my highest y? 0 again. And then I follow behind with not y. F of x. Is an element of the real. If it had been y equals, those f of x are just y's, right? No big difference. But it does matter when you get to grade 12, because they'll use f of x instead of g of x, they'll use y, so use h of x. You have to actually use a variable gate. Okay, what's happening here? I just moved the a value, what was in front of the x squared last time, right? That's all I was doing. This time, we're keeping this as x squared, but we're just adding a q to the back. We're just adding a number behind the x squared, and we're going to see what happens. So instead of writing f of x, we're going to write these as y equals just for practice, so that we can do our range in y equals. Okay, so I'm going to cross them off as f of x's, and I'm going to write them as y's, so we can get used to writing range in y's as well. Does that make sense? Okay, so we're going to go to our calculator, and we're going to type in x squared into our y1, and x squared plus 4 into our y2. So I'm going to clear these out. Remember when you clear them, you take out the thicker. So you need to go to that slash line and hit enter again when you clear it, because it just takes that thick line out for y2. So in y1, I'm going to go x squared. And in y2, I'm going to go x squared, I don't remember what it was, plus 4? Plus 4?
Yeah.
So do you see that that 4 isn't with the x? It's at the very back, isn't it? I do the x squared first, and then I put a plus 4, so it's not with the x. Do you agree? Now press, go over, make yours thicker if you haven't. Go over to your slash, hit enter once, and then press graph.
Can you, is there a way to make it like third one?
No. I went through all the options. You want another one?
There's a bunch, there's a dotted.
Yeah, but they don't show a proper graph.
I didn't look at them all. I think.
Of course you did. Okay, there's the x squared. Oh, boom! What happened? Where did it move? Up, well, how many? 4. What was at the back of the equation? Holy dynamite. Perhaps there's a correlation. I don't know. I'm going to draw it. So we're going to go second, trace. Actually, before we draw that, we need to find the what? What should we always find first? The vertex, and in this case, it's a what? Is it a min or a max? That red one. It's a minimum because it's concave up, so the graph is at that lowest and higher, right? So we want to find the minimum, the vertex of the red. So we're going to go second, trace, minimum. So we should always find first. I need to pop up onto the red one. If you're not on that one, you need to arrow up to get onto it. I need to go on the left side of it. Enter. Right side of it. Enter, enter. And I get e to the negative 6, which is 0 and 4. So I'm going to go over here before I even do any of the drawings, and I'm going to say, hey, my vertex is at 0, 4. And then I'm going to go sketch it. I'm going to make my y scale be 2. We're going to run out of room really quickly. Y scale 2, x scale 1. So 2, 4. So I plot my 0, 4, correct? Then I go to my table of values and I pull values to the top, above 0, 4 and below 0, 4. So I go to my table of values. I know 0, 4 cuts it in half. And I go second table and I find 0, 4. I'm going to clear out the full ones. So I find 0, 4. And then I take some this way and some this way. You see that? So 0, 4 is my vertex. I'm going to take these ones and plot them, and these ones and plot them on either sides of it. Make sense? I want to take a picture of them so I can plot them. Okay. So I'm going to plot Negative 3 and 13. Why can I plot 13? Because I made the y scale be 2. So negative 3 and 13. 1, 2, 3, 2, 4, 6, 8, 10, 12, 13. And then I have negative 2 and 8. Negative 2 and 2, 4, 6, 8. Then I had negative 1 and 5. 2, 4, 5. Then I had 1 and 5. 2 and 8. Everything about quadratics, they're symmetrical. There's like one side. The other. You see how I'm curving the bottom a bit? I'm not doing a perfect V. Because quadratics, parabolas don't have a V, a point at the bottom of the curve. Did everyone see how to draw that? Anyone have questions? Remember, you guys are kind of like fresh calculator people. So you're like noobs to calculators. So if you have questions, when is the time? Did you figure out how you can draw that? Can you draw that?
Got the drawing.
That's all I want. Okay. Can everyone draw it? That's all I really want right now. You can draw it, and you can sketch it. Was everyone able to find the minimum, which is the vertex? Okay. We should be able to answer every question now below once we get the vertex. What's the direction of the opening of that red graph? It's up. What's my range? Well, I put in y equals, so I'm going to go y such that y is 4. Right? It's greater than because the whole graph is above. Whenever you have a minimum, it's greater. Greater than or equal to, what's my lowest y on this graph? 4. Acceptably, you're going to try and say 2 half the time because it's y scale of 2. So you have to remember that, okay? So it's 4. And then y-er. Where did this number correlate with? That back number, that cube, eh? Because I took a graph that was 0, 0 and I moved it 4 out. Now it's 0, 4. That's what that back value does any time. What's my domain? My domain is happiness. It's just x, such that x and L are the reals. Because I can go, boom, out like this. My axis of symmetry is always x equals the x of the vertex. And what's the x of my vertex? 0. What's the x of my vertex? 0. What's the line that would cut this in half vertically? The y-axis. And what's the equation of the y-axis? It's actually x equals 0. The equation of the x-axis is actually y equals 0. Horizontal lines are y equals lines. Vertical lines are x equals lines. Remember that equation. Okay, I want you to type into your calculator, figure out everything. Type in just y equals x squared minus 3 and try and draw it. Okay, that's what I want you to do. Y equals x squared minus 3 and try and draw it. What's the first thing you're going to have to look for, though? The vertex. Is it minus 3?
Yeah.
You find the vertex first. Once you find the vertex, you're going to take some points above the vertex off your table of values, some points below the vertex off your table of values, and sketch it. We're working on sketching right now, because unless you can sketch the graph, you can't answer any questions. So we're learning our graph. We're learning our calculator. You tried. So I'm going to go second, trace minimum. Left bound, enter, right bound, enter, enter. And then I know it's at 0 and negative 3. So I go to my table of values, and I find 0 and negative 3, which is here. And then I pick values above it, values below it. The more you put on, the better you are. So I'm going to go. My vertex is at 0 and negative 3. I write that. I go over here and I go to 0 and negative 3 and I draw it. Remember that we have a y scale of 2. Then I pick on the left side of it. Negative 1 and negative 2. Negative 2 and 1. Negative 3 and 6. Negative 4 and 13. then it's symmetrical. 1 and negative 2, 2 and 1, 6. So it still goes out for life, correct? So my domain is still x such that x and out of the rails. My range, or sorry, what would be direction of opening, is still up. My axis of symmetry is still x equals 0, because all I'm doing is moving down 3, correct? And why is it still up? I used a negative 3 at the back. Why is it still up? Yeah. Yeah, because the x, there's a positive for that x squared, right, which causes the up. The only thing that's going to drop that baby is putting a negative in front, right? The negative makes it up or down. All that q does, all that number at the back does is does this. Up 4, down 3. Like it just literally moves you up and down. That's it. I haven't moved over to the right or left at all, have I? Up or down. And they're both concave up because they have positives in front. Okay? So my range this time is going to be y such that y is greater than or equal to, and it's greater than or equal to, but it's still concave up. My lowest value, which is negative 3, y star. So now I'm going to talk about the value of q. What does the value of q do? Q is greater than 0. What's going to happen to my graph? It's going to move up. Because that means q is positive. And if q is less than 0, which means it's negative, it's going to move down. And then move over. Ah, what's happening here? We now have something in the bracket with the square. See that? We call it a p. So, go to your calculator. I'm going to put y scale up to x scale with 1. We're going to type in x minus 2 squared into our calculator. Bracket x minus 2 bracket squared. See, I just typed it in. That's the way it is. Bracket x minus 2 bracket squared. So now it's with the x now. It's not just at the back behind the x squared, correct? It's with it. And it's a minus 2, isn't it? So if the q moved it up and down, what do you think the p is going to do? Move it side to side, right? Now if q is positive, I move up. Q is negative, I move down. So some people will be suspicious to say, if p is negative, I'm going to move left. But let's see what happens. I moved right. It does the opposite. If it's x minus 2, we're actually moving 2 to the right. And if it's x plus 2, we're actually going to move 2 to the left. So let's find the minimum here. Second, trace, minimum, left bound, enter. Right bound, enter, enter. So it's at 2. I don't care about these, if I'm rounded, that's 2. And then e to the negative 12, which is 0. So how do I get the rest of my values? I go second, graph, I find 2, 0. And I pick some above, some below, and I still plot the 2, 0, right? So, you know, what? I don't get it. What? Oh, I thought like it was meant symbolic or something. I was like, you went like this, and I was like, 2 hamburgers. 2 pieces. Got it. It was literal. I didn't know that. I was reading into it. Shouldn't have done. All right. So we have 2, 0 as our vertex. Sidetracked me. I was going to make an error. Okay, 2, 0. And then I have 1, 1, 3, 1, 0, 4, 4, 4, negative 1, 9, 2, 4, 6, 8, and then 5 and 9. You always extend because a little bit of error looking at. So my vertex is at 2, 0. What's the direction? Up. Why is it still up? Because there's a nothing there. There's a positive sign in front, correct? I need a negative in there to make that baby go down. Okay, what's my domain? It's still praising. Still like, on its side. So it's still x such that x now is the reals. What's my range? I'm gonna label it y for ease. Y such that y is, it's concave up, so greater than or equal to, what's my lowest y value? 0. YER. And what's my axis of symmetry? It's always been x equals 0, but this time it's actually x equals 2, because it's the x of the vertex, right? What do you think is going to happen here? X plus 1. It's going to take my graph and move it 1 to the left, the opposite way. Right? That's all that happens. So let's go down here. Describe what happens. If I have x minus p, I actually move p to the, it's x minus p, when we're moving, p to the right, so it's the opposite. Q is exactly what it is. If Q is positive, I move up. Q is negative, I move down. But if P is negative, I actually move right. If P is positive, I move P to the left. We have a little summary. What does the A do? If A is greater than 0, what happens? It's concave up. Greater than 0 means positive. It's concave up. If A is less than 0, it's negative, and it's concave down. And then we said if A was between -1 and 1, the graph got wider, right? If A was less than -1 or A was greater than 1, it got narrower. We just said this. If it's x minus p squared, I move p to the right. If it's x plus p squared, I move p to the left. If it's q is greater than 0 or positive, I move q up. If q is, that is a G. What is going on? If q is less than 0 or negative, I move q down. I said down. So we're going to take that into our heads. Tomorrow we're going to finish this lesson, start on some homework, because we only have a little bit left. We're literally just review. I'm giving you equations down with numbers, and you're going to tell me things about it. Okay? Then you're going to work on some homework with that, and then we're going to actually start the next lesson tomorrow. We won't have the other quiz. Okay? So we'll go back to the other on Thursday. So tomorrow we're just going to finish up this lesson, or I give you an equation with numbers, you give me the vertex, the main, the axis of symmetry. And work on some homework, and then we're going to start the next lesson. So tomorrow doesn't do the quiz. Okay? Which means tonight you don't have anything. That's 2 in a row. You should throw yourself a little party. That's rare. It's more rare than an eclipse.